Hello and welcome to building iBeacon apps using Xamarin. So what are we going to cover in this video? So I'm going to start with talking about the basics of an iBeacon app and how you develop one, so what monitoring is, what ranging is. Then we're going to actually get our hands dirty and start creating some code. So we're going to start with Hello iBeacon, which would be a first iBeacon app to monitor a beacon, a fairly standard use case. And then we'll follow up with a Where Am I app. So we're going to take our monitoring app and extend it further to allow us to range beacons, which means detect the signal strength from a beacon and work out which beacon's closest to the phone. So what are we not going to discuss? So this is very much a hands-on technical video. It's going to involve some coding in a minute. We're not going to discuss the whys and wherefores of beacons. So we're not going to talk about the different use cases, using beacons for indoor location, context-aware apps and what they are. We're not going to talk about iBeacon security, loads of other things. So that should be coming in a future video. For now, it's just going to be hands-on with the code. So what will you need? So if you want to follow along with the code and actually do these demos yourself, you're going to need a couple of things. The first thing you're going to need is an actual iDevice to test on. So an iPhone or an iPad running at least iOS 8. Unfortunately, the simulator doesn't support iBeacons, which is a bit annoying. And then you're going to need a couple of iBeacons themselves. So if you don't have any iBeacon hardware kicking around, then there are apps you can get for your iPhone or iPad to allow you to simulate an iBeacon. So you can turn a second iPhone into an iBeacon. If you just go into the App Store and look for something like the Estimote app, that's got a virtual beacon on it. So that way you can get a second iPhone set up as a virtual iBeacon for testing purposes. But I strongly recommend, if you really want to get into iBeacons, buying some hardware such as the Estimote developer kit, $99 US. It's really good. So let's talk about how do iBeacons work. So an iBeacon is a Bluetooth beacon in that it broadcasts out a signal, the same as real-world beacons such as lighthouses. And this signal is sent over Bluetooth Low Energy, and it contains an ID. It's a multi-part ID made out of a proximity UUID, which is a GUID, and then a major and a minor version number. And it also has a measure of the transmission power of the beacon. So this is something that's set by the manufacturer to say how much power, so what is the strength of the signal that's being broadcast by the beacon. And that's sent out over Bluetooth Low Energy on a periodic basis, every 100 milliseconds or so. And now this is just a one-way communication. So the beacon transmits a signal. That's it. There's no pairing involved. There's no two-way communication from your phone back to the beacon. Simply the beacon sends out a signal, and any device that supports Bluetooth Low Energy is able to detect the signal. And in the case of iPhones, iPads, the iOS operating system has inbuilt code to allow your apps to respond to this whenever it detects a beacon that you're interested in. Now, the way you interact with a beacon is through a beacon region. So similar to how with core location you have geographic regions, you can also define a beacon region. And that is defined as all the beacons that have a specific ID, and then optionally a major and minor version number. So you can create a region for one ID and have 20 beacons that transmit that ID, and all those beacons would be considered one region. Or you can have 20 beacons each with the same ID but different major and minor version numbers, and you can have one region per beacon. Now, one thing to be aware of is there is a limitation in iOS of 20 regions per app. So when you're creating your regions and registering interest in them, there is a limitation, so don't go mad with regions. Now what your app can do is it can monitor or range a region. So monitoring a region means your app will listen for when you enter or exit the region and then allow you to respond appropriately. Now this monitoring happens in the background. So once your app has been run once and registered interest in a region, then if the OS detects you entering or exiting that region, it'll activate your app. So if your app is in the background or your app has been terminated, it'll get woken up and you'll get your standard 10 seconds or so of background time to deal with the fact that you detected this beacon. So this allows you to put a beacon somewhere, somebody walks past, their phone wakes up, they get a notification to say they're by the beacon. The next thing you can do with regions is you can range them. Now, ranging only happens in the foreground, and this is where your app detects the strength of the signal from the beacon and then gives you a relative signal strength indicator, which is a kind of a distance measurement. There is maths you can do to convert that to meters. Obviously it's very hit and miss because the signal strength could be interrupted by walls, people, etc. So it's not a straight conversion, but it's a useful way of determining which beacon is closest to you if you're in an environment that's got multiple beacons. So monitoring in the background wakes your app up when you enter or exit a region. Ranging in the foreground gives you the relative signal strength of the region. So how do we code against them? So like geo regions, you have to use core location. So use the CL location manager, same as you would when you're doing GPS monitoring and ranging. Now, because you're using core location, you have to be authorized. You can't have your app just monitoring your location without your say-so. So before you can interact with a beacon, you have to ask for authorization. And like any location-based authorization, you can either have it when the app is in the foreground or at all times, so when the app is in the background as well. And obviously once you have that authorization, then you can monitor or range for iBeacons. So monitoring only makes sense when your app is in the background. Your monitoring doesn't work when your app is in the foreground. So if you're going to use monitoring, you need to get the always authorization. If you're doing a region, you just need the when in use authorization. So let's write some code. So first thing we're going to start with is just the basic setup. So creating a location manager and requesting authorization. So I'm going to zip to Xamarin Studio, and I'm just using a simple single view application that I've already created, nothing fancy here. So the first thing we need to do is we need to have a location manager. So we'll just declare one in our app delegate. And obviously bring in core location. And then once our app has finished launching, we will create it and use it. So location manager, just create a new one, nothing fancy there. And then we need to request authorization. So there is a request always authorization and request when in use authorization methods you can call. Obviously, they do different things. So we want request always authorization because later on we're going to start adding monitoring, and to get monitoring we have to run the background. Now, once your location manager is authorized, you then need to start doing whatever you want to do. So to do that, you need to handle the change in state. So on the location manager, there's an authorization changed event. So we'll add a handler to this, give it a slightly nicer name than the Xamarin default. And in here, all we'll do for now is just dump out the console what our state is. And just resolve that. So in terms of code, this is all we need to do. Now, we want to set up the event subscription before we call request always authorization, because if our app has already been authorized, this will literally happen straight away. So we'll call this, and the OS will say you're already authorized. You only have to, the user only has to say yes once or no once. Now, before we can actually request authorization, we have to do a little bit of magic. So when the box pops up to ask the user whether they want to authorize your app, there is a little description there that explains why your app needs GPS access, location access, sorry. And you have to set this message before it will work. If we just run this like this, nothing will happen. The user won't be asked. So what we have to do is we have to add an entry into our info.plist to give the description that gets shown in the pop-up box for the user to say allow or don't allow. Now, this isn't a standard info plist setting, so it doesn't appear in the info plist editor. You have to drop straight to source and add a new entry. This is a string entry. So what we have to add is ns location always usage description. We need this because reasons. So the NS location always uses description is what's shown when you ask for access always, so when the app is the background as well as foreground. If you're just doing it when the app is in the foreground, then it's NS location when in use usage description. Now it's very important you set this because otherwise it doesn't work. So if we just launch this and zip to my iPhone, when it builds, we should see it launch and we should see permission be requested. Okay, and here we go, and there we go. So as you see here, we need this because reasons. So this came from our NS location always uses description. You notice as well, we have some debug output of a status of not determined. So this authorization change is fired every time the status is set, and even the initial status of not determined, the event gets fired for that. So if we click allow, you'll see down here the status is authorized always. So our app is now authorized to access the location even when it's in the background. Okay, so that's the basic setup. Next thing we're going to do is create our Hello Beacon app. So this is where we create a beacon region and then we start monitoring for that region. So I'm going to just open up another project just so I can copy and paste a bit of boilerplate code in. Nothing too important, just IDs. So while that's loading, let's flip back to our project and we'll carry on. Okay, so in our authorization change method, this is where we know that we're now authorized or not. So in here, we need to check that we're authorized. So if our status equals authorization status authorized always, we can actually start doing something. So here is where we want to start monitoring for our particular beacon region. And we do that with our location manager, start monitoring. Now for this, we need to give it a region. So this takes a CL region. Now, beacon regions are derived from CL region. So let's just create a beacon region. This is what we're interested in monitoring. And we'll just, and let's just create it here. Now, with the CL beacon region, there's 3 constructors that we care about. So the first one takes an NSUUID, is the proximity ID. This is the first part of that 3-part ID I mentioned earlier, and an identifier. So this is the name of the region. So whenever you create a region, it has to have a name. Second one, same fields, but we also have the major. So the first one, we just say any beacon with a particular ID, don't care about the major and minor. Next one, any beacon with an ID and a major, don't care about the minor. And the final one, any ID with a specific ID, a specific major, a specific minor. So this allows you to set the granularity of the regions if you have multiple beacons around. We'll just go for the simple case, just with the proximity ID. And I will just steal this ID from my other app because I'm too lazy to type it in. And we'll give this a name. Okay. and then we pass that region in to our start monitoring. Now obviously we want to know when the monitoring has happened, so on the location manager there is a region entered event. So we'll just sign up to this, again give it a slightly nicer name, and a region exited. So region left, sorry. Again, we'll create an event for this. Now these events get fired when you enter or leave a region. So when it first detects a particular beacon, and then when it stops detecting that beacon. And you can configure whether these events get fired or not. There are some properties on the location manager that allow you to do this. So you can sorry, it's on. Yeah. So it's on the region. You can say notify an entry, notify an exit. By default, these are true. And this allows you to say in your region that I only want to be notified when I enter the region, or only want to be notified when I exit the region. Or you can say notify entry state on display. And this means only notify when I enter when the app is in the foreground. So in the background, don't do anything, just do it in the foreground. So it gives you a bit more granular control over what you want. For now, we'll leave those as the defaults, which is always notify us. So now we're monitoring and we've got events being fired. But obviously our app's in the background, we have to do something to show that this has happened. So let's just set up some local notifications. To show this, this is just basic local notification code, nothing special here. So what we're doing here is when we enter a region, we do an alert to say, hello iBeacon. When we leave the region, we say, goodbye iBeacon. Very simple, these appear as local alerts. So I will just demonstrate this. Sorry, bad code there. Unfortunately, you can't just pass in a string here. You have to pass an NSUUID. Okay, it's built. Let's deploy it and let's run it. So this app is now run, and because we're using the local notifications, we just okay. Okay, so app's now running, which is fine, but we're monitoring, we're interested in the background. So let's just kill the app, and I'm just going to simulate entering a beacon region. I'm actually using some estimate beacons that you can switch off by turning them upside down. So I'm going to turn my beacon on to simulate entering a region. There we go. You notice local notifications. My app's in the background, but it's still responded. And now I've just turned my beacons off. But you'll notice we don't get that notification instantly to say that the beacon's gone. Instead, we have to wait about 30 seconds because you don't want your app to not detect a beacon and instantly think you've left that particular region. There could be a reason why it's not been detected. The signal's got lost as you move around, or something's got in between you and the beacon and then you move back into range. So rather than instantly, there you go, that's it. So 30 seconds afterwards, you get notified. It doesn't happen instantly, it's 30 seconds after it loses the signal. So there we go. We've just demonstrated how to use monitoring so that your app gets woken up when you enter or exit a beacon region. And you notice as well, if we look at the application output, all we have is authorized always. So whatever happens, whatever authorization state your app is in, the authorization change event will always get fired. So even if you've authorized it, that authorization change will get fired. So this is the best place to put your code to actually start monitoring or start ranging after you've been authorized. Okay, so that's Hello Beacon. Now let's move on to part 3, which is going to be a where am I? So in this example, we're going to set up region ranging, and we're going to range 2 regions to try and work out which one is closest. So which iBeacon out of 2 beacons are we closest to? So first thing is we're going to move this code from our app delegate into a view controller so that we can show things on screen. Let's get through and do in my view did load. I'm going to create my location manager and handle everything. Just delete my code from the app delegate. So for simplicity's sake, I'm going to do it all in the view controller. Let's just resolve everything. Okay. Now the first thing is we're not interested in region entered and region left anymore. These are for monitoring. Instead, we're interested in ranging. So we want did range beacons. This is the event that's fired every time you range a beacon. Now, once you start listening for this, once you start ranging beacons, this event will be fired on a regular basis, even if there aren't any beacons around. So once you start ranging, this will constantly get fired. So one thing you have to be aware of is the beacons collection could be empty. So it's always worth checking if there's any there before you do anything. Okay, so in this, as mentioned, we're going to look at the distance between two beacons. So both these beacons can have the same proximity ID, so we can use one region for both, but we're going to see multiple beacons appearing as we range them. So if I just start by dumping out to the console the beacons we find, we should see multiple beacons. So we loop through. Let's loop through all the beacons, and we've got beacon.proximity ID as string. This is an NSUUID, so if you go to string, you get a nice representation of the tower object. If you go as string, you get the normal GUID type string that we're used to. And then we want beacon.major, beacon.minor. And then what we'll add on as well is the RSSI, the relative signal strength indicator. And this is what we're going to use to work out which beacon is closest. So if we now want to start ranging instead of monitoring, start ranging beacons. So what we're doing here, we're saying we want to range these beacons rather than monitoring because we're in the foreground, and then when they're ranged, we go through all the beacons we found and dump them out. We'll just stick a breakpoint there for now so we can see what comes through each time. Right. So let's just run this. Okay, so the first time it's run, we have 2 beacons. And I've just turned these 2 beacons off, so if we just run it for a little bit. Okay, no beacons. So once you start ranging, this event will be called on a very regular basis, regardless of whether you have any beacons there. So you must check your beacon collection. You can't assume there'll always be beacons there. So if we run this, and I just enable my beacons, you'll see we have 2 different beacons being dumped out. So both have the same proximity ID, but have a different major and minor version. And let me just fix this little bug. So hopefully this time we should see the RSSI. Now this RSSI is a relative signal strength indicator. So it's a measurement of the relative amount of the signal that you've received. So it's not directly based on actual power, because each beacon transmits a different power. So the idea being that if it doesn't matter what transmission power you have, you should, as long as all your beacons transmit at the same power, the lower the RSSI, the closer the beacon. And now these RSSI numbers are actually negative numbers, so it's lower the negative number is, so the higher the number. So you see here we've got an RSSI of 52, 58, sorry, minus 52, minus 58, etc. And then sometimes there's an RSSI of 0. So let's just move 1 beacon so we get some big differences. Yeah, so you'll see now that the 15274 beacon, the RSSI on, let's just break one in to stop it. The RSSI on that's 79, and on the 9358 beacon it's 49. So this beacon has the smaller negative number, so this is the closer beacon. So one thing to note though, occasionally it comes through as 0. Now 0 means it wasn't able to make a measurement. So the signal was received, but there was no measurement made successfully of the transmission power. So you pretty much just ignore anything with a 0. So if we now stop this and just implement that, a little bit of link here. So it's less than 0 because it's a negative number. So that way we're only going to get the beacons that we care about. Now in terms of which is the nearest, we need whichever one has the smallest negative number. So let's measure this. So what we do, we'll go through each of the beacons, and then a simple bit of logic to find which is the nearest one. So nearest is null. Nearest beacon. So if it's not null, if you want it nearest, if the beacon RSSI is greater than the nearest RSSI, so this should get us the nearest beacon. And then we want to display this on screen. So we'll just fire up our storyboard, drop in a label, and dump this information out to the label. So, drag on the label, give your name, and then just to make it look nice, we'll open up an Xcode interface builder and set the constraints in there so it sits in the middle, because it's much easier doing it in Xcode than it is doing it in Xamarin Studio. Okay. Add our center constraints there. Save that. Okay. So now we have our label created. We just need to build so that our label's there, and then we can set it. So if you haven't detected anything yet, our label can just say no beacons found. Otherwise, we'll set the text to be we'll just set it to show the major and minor of our beacons. And there we go. So what we're doing here, we're saying range the beacon through all the beacons that have actually got an RSSI set. We'll dump it out the debug window, and then we'll find the one that's got the highest RSSI. Now we're only taking into consideration the ones where the RSI is not 0. So all the ones we have an RSSI for, find the one with the highest, that's our nearest beacon, and we'll dump out its major and minor to the UI. So let's just run this. Okay, there's no beacons found, but currently my beacons are switched off. So if I turn one on, I've just got one on, and you'll see the nearest beacon is 93585594. So that's the one that I've enabled closest. Now you notice it keeps flipping back to no beacons found. That's because we keep getting these RSSIs of 0. So obviously in proper code you'd want to handle that better. So now I'm going to enable another beacon and put that one closer. So you see now my nearest beacon is 15274. And if we look in our debug console, 15274 is an RSSI of minus 53 and 9358 is minus 59. So let's just move that even further away. So 9358 is minus 80, 15274 is minus 55. And that's why we're seeing that. And if I swap the beacon locations around, 9358. So from here you can see that using this RSSI is an easy way of determining which beacon has a stronger signal. Closest makes sense in terms of empty space, but your closest beacon may not actually be the closest. The beacon with the closest RSSI may not be the closest because there could be things in the way. So, for example, if I put one beacon a long way away, and then have the so it now says that 9358 is the closest beacon, but if I move 9358 to be still closer, but it's now hidden behind me, you'll see 15274 is the closest beacon. So what I'm doing here, I've got 15274 is about a meter away from my phone. 9358 is about 10 centimeters away, but it's underneath my leg. So the signal just passing through me is enough to make it seem like it's further away than a beacon that is actually further away. So something to bear in mind. Okay, so that's the end of part 3. In the source code for this, which is available on GitHub, there's another example, but using 2 regions instead of 1. So check that out if you want to see how you can use multiple regions and find them via their region ID. So that's it, we're done. So in this video, we looked at the basics of how iBeacons work, their IDs, ranging, monitoring. We looked at how to authorize an app so that you can work with iBeacons. And we looked at how to monitor so your app can wake up, and range so your app can get distance iBeacon regions. So thanks for watching. You can download the source code for this on my GitHub. Links here. And you can follow me on Twitter at JimBobBennett, or you can read my blog at jimbobbennett.io.